Exploring list and array operations in Python. Introduction. Hello everyone. I hope you are all doing well. In this tutorial, we will explore as many list and array operations as we can. In actual sense, the concept of lists and arrays do not differ much, nor does the features each support. The major difference deals with the fact that elements in arrays belong to the same data type, while elements in a list will be of different data types. First, we will attempt to cover the operations that may be performed on arrays in Python. So, to begin this lesson, we head over to our IDE. I will be using Spider IDE for this tutorial. Let's get into it. Creating your array. We will first create our array. Let's assume we have an array of Netflix movie rating percentages. Let's say we have 5 elements in this array. We will populate our array with 5 values. You may make the movie ratings floating point integers or standard integers. Movie ratings is equals to 90, 68, 34, 80, 98. So, with regards to the operations that can be performed on these arrays, printing our array. We are allowed to print our array to the screen as output. Print movie ratings. Output will show as follows: 90, 68, 34, 80, 98. Accessing individual elements. Indexing. We are able to index our array as follows. Let's print the first element only from our array of movie ratings. Remember, Python sequences are 0 indexed. Print movie ratings 0. Output will show as seen below, 90. Slicing arrays. Slicing involves picking out specific portions of larger arrays to make viewing easy. It helps when we are interested in only a specific section of the array. We slice an array by specifying the name of the array we are interested in, followed by the start and stop index position of the elements within a pair of square brackets separated by a colon. The operation is inclusive of the starting index and exclusive of the ending index. Slicing syntax is done as follows. Array name, start index, colon, end index. Array we wish to slice, index position to start slicing operation, colon separating the start and stop index. Slicing will stop at end index minus 1. For example, let us create a slice of our movie ratings array that will show us the first 3 movie ratings. Since we wish to have returned the first 3 elements, remember Python is 0 indexed. This means that we will be starting with index position 0 and we will be ending at index position 3. Take a moment to see the diagram below. 90, 68, 34, 80, 98. Index positions 0, 1, 2, 3, 4. Notice, we will start at 0 and end at 3. The technique of slicing is not inclusive of the end position integer. Therefore, we will only be outputted with the elements at index position 0, 1, 2, which will effectively give us the 3 elements we wish to receive. Print movie ratings 0 to 3. The above slicing operation will give us the below output: 90, 68, 34. We are also able to set a slice of one array to be equal to a new array. We will then be allowed to operate on that new array without changing or affecting the elements in the original array. For example, sliced movie ratings is equals to movie ratings 0 to 3. Print sliced movie ratings. See, we have created a new variable who will hold a sliced portion of the original array, and we can perform operations on the new array just as any normal array. Output will be seen as follows. 90, 68, 34. I would like to mention that just like how we may return the first element of an array by specifying an index value of 0, we are also able to obtain the last element in the array. The way in which we do this is by specifying the index position of the last element. When working with indexing backwards in an array, we work with negative indices. The index position of the last element starts at 1. Therefore, the last element in an array will be indexed using the index position -1. For example, print movie ratings -1. Output will show as follows: 98. Now, sometimes we may not know exactly how many elements exist in an array from a certain point. For example, from element 2 up to the end, that is, everything in the array from element 2. In this case, our index start will be 1. However, what if we had a very large array in which we do not know the end index value? It is in times like this when we would make use of a colon. A colon is equivalent to the word all or the rest. So, if we would like to get all elements from an array from the second including the second up to the last one, we could do it as follows. Again, a reminder that Python slicing is inclusive of the start index and exclusive of the end index when integer values are specified. By using the colon, we effectively mean that we wish to get all values including the last value. Print movie ratings 1 colon. As seen above, we have started slicing at the second element in the array and have used the colon to specify all or the rest. We have therefore specified that we would like to include all values from the second up to the last in our slice by using a colon. By using a colon, we tell the compiler to include all elements. So in simple terms, we are telling Python to start slicing at the second element and end at the very last element. I apologize for the repetition and redundancy of information in the previous sentences. I just wanted to make sure the main idea was gotten. You will see output as follows: 68, 34, 80, 98. Providing a step. Do you remember the syntax we saw earlier for slicing an array in Python? If so, you will recall that it went something like this: array name start index colon end index. Now, I would like to mention that there is a third argument which you may pass into this syntax. It is called the step index. So basically, another variant of the slicing syntax looks like this: array name start index colon end index colon step index. So, using the syntax for steps, let's assume we require all elements from the first till the last and in steps of 2. So we will specify values as follows. This means we would like to obtain elements from the first, third, and fifth values in our array. We would provide a step of 2. We would code it as follows: print movie ratings 0, -1, 2. Output will show as follows: 90, 34. Notice the array we had was 90, 68, 34, 80, 98. And upon slicing the elements from the first till the last and every second element, we were outputted with 90, 34. The question is, why wasn't 98 included in the output? Because it meets the specifications of the steps. The answer is because we have specified an explicit index of -1, slicing operations are inclusive of the start index and exclusive of the end index. Therefore, it has not been included. To give you a diagram, Now you see, it is in times like these when the use of a colon is feasible. So essentially, we would like to get all elements from the array with a step of 2. We will code the slicing syntax as follows. Print movie ratings colon colon 2. Output will show as follows. 90, 34, 98. Notice that now we have obtained every alternate element in the array. That is the power of the colon. You would also notice that the use of colons affect the general syntax of the slicing operation, but that is nothing too difficult. With programming, and especially in a programming language as user-friendly as Python, no concepts are too difficult to learn and understand. One just needs to understand the logic of the concept. The default value step is 1, which is why we don't include a step value when we are slicing consecutive elements. An interesting operation is the concept of reversing the contents of an array. This is done by using normal slicing techniques. Reversing an array. The way in which we reverse an array is as follows. Print movie ratings colon colon -1. What happens above is that we are slicing all elements in the array from the first till the last, but we are going in steps of -1. This means that our array slicing will start from the first element and end at the last. However, condition is steps of -1. Therefore, the stepping and checking of elements start from the end of the array. Output will show as follows. 98, 80, 34, 68, 90. Logic of reversing an array is the same as saying, I want returned all elements in the array, but from this direction. Adding elements to an array. To add elements to an array in Python, we simply make use of the append function that is offered by Python. We would do it as follows. Movie ratings.append 90. Looking at the above syntax, we simply specified the name of the array followed by a dot and the word append. Within the append function, we pass in a piece of information to append to the array called movie ratings. Output will show as follows. Print movie ratings 90, 68, 34, 80, 98, 90. Notice that the append function in Python will add the past value to the end of the array. In our case, notice that a new integer value of 90 has been added to the movie ratings array. I should mention to you that we are allowed to append information of any data type to arrays, not just integers. For example, you may append Boolean values or even strings or even floating point integers. Example, movie ratings is equals to 90, 68, 34, 80, 98. Movie ratings dot append 90, movie ratings dot append 78.98, movie ratings dot append true, movie ratings dot append Spider-Man No Way Home. Print movie ratings. Output will be seen as follows. It's just that after deviating from working with constant data type of integer, by adding information of other data types, we are now working not with an array but a list. There is nothing to be concerned about this though, because features supported by list and arrays remain the same. Clearing a list. Notice that because we have different data types in our array, we are starting to call it a list from this slide onwards. Again, I would like to mention to you that lists and arrays support abundant features that are similar. To clear a list of all contents, we simply make use of the clear function available to us in Python. The way in which this is done is as follows. Movie ratings dot clear print movie ratings. And sure enough, as we expect, all contents and elements of the list have been removed and the list is empty. Creating a copy of a list. In some programming instances, we would like to conduct experiments on a variable without affecting or changing the original. It is in times like this when a copy function is useful. In Python, we can create a replica or duplicate of the list by using the copy function available to us. For example, if we would like to create a copy of our movie ratings array, we would do it like this. Movie ratings copy is equals to movie ratings dot copy. Print movie ratings copy. And sure enough, all elements will get copied from the original list into the copy. Output will show as follows. And we would be able to manipulate and operate on the copy of the list instead of changing the original. Counting items in a list. The term array and list are used interchangeably in Python. So let us assume we have an array in Python that is representing a shopping list. So we have a shopping list, but it is not convenient for us because in order to get the total number of times a particular item appears in the list, we would have to physically count it. But in Python, we have access to the count function. The count function will allow us to pass in a value and it will attempt to count the number of instances the value appears in the list. For example, if we would like to count the number of times apple appeared in our shopping list, print shoppinglist.count apple. And sure enough, the number of times apple appears in our list gets counted and is returned to us as output. You will see output like this. 4. Strings are not the only items you can count. If we had an array with movie ratings, for example, we would be able to count the number of times a particular value appeared in the array by passing in the appropriate integer or floating point value as an argument to the count function. Appending more than one item to a list. So, as we have seen earlier, the append function will allow us to add items to a list or array. However, the append function will typically be used by programmers to add one and just one item at a time to a list. There are certain times when we would like to expand our lists and arrays by more than one item. That is, we need to append several items to the list in succession in order to grow our collection. To do this in Python, we make use of the extend function. This function will require that you pass in all items that you would like to append to a list in the form of a list. So for example, let's assume that we would like to append these values to our list. Orange, orange, apple, bread. One way to do it would be to use the append function 4 individual times to achieve what we want. So using the append function, we would do this. Shoppinglist.append orange, shoppinglist.append orange, shoppinglist.append apple, shoppinglist.append bread. The above image depicts one approach to append 4 additional items to our list. However, it is not convenient for a programmer. So, our alternate and feasible approach would be to use the extend function. We would attempt to do it as follows. Shoppinglist.extend orange, orange, apple, bread. The output of our procedure will be the same irrespective of the approach you use. Whether you use the append function 4 times or extend function 1 time, the approach you use would just be based on your convenience. Output of our list after the appending and extending process would be as follows. Getting the index position of an element. The index function in Python will allow you to get returned the index position of the specified item. It is important to note that the index function will return to you the index position of the first item that matches your specification. For example, if we would like to see the index position of the item apple in our list, we would do it as follows. Print shopping list.index apple. Output to the above line of code would show as follows. 2. Notice that we obtain output of 2. This is because the first instance of apple occurs at index position 2. The index function will return to us the index position of the first occurrence of the specified item. Inserting an element. Just like how we use the append and extend function to add and append elements to the back of a list, we may make use of the insert function to insert an element at a specific position in a list or array. The insert function will accept two arguments. The first is an index position in the form of an integer. This index position is the index position at which you would like to add a new element in the list. The second argument is the value you would like to insert at that particular index position. For example, let's assume we have a simple array with student marks. We have an array in which there are 5 student marks for a test out of 50 marks. Exam marks is equals to 45, 53, 49, 39, 35. Upon looking carefully at our array, you notice that the mark for the 6th student has not been captured. So, we will use the insert function to add the element to index position 5. We will do it as follows. Exam marks.insert 540. Print exam marks. And upon printing the list, we will see that an element has been added to index position 5. Output will show as follows. 45, 53, 49, 39, 35, 40. I should mention that we are allowed to insert an element at index positions where elements already exist. It's just that the index positions of elements after the point of insertion get incremented by 1. For example, let us insert an element at index position 2. Exam marks.insert 230. Output will show as follows. 45, 53, 30, 49, 39, 35, 40. Notice that we have a new element at the index position 2. It is the element that we have inserted at that point in the list. And notice that the index position of all elements after the point of insertion has been incremented by 1. Removing an element from a list. In Python, if you would like to remove a specific element from a list, you may make use of the pop function. Within the pop function, we pass in an integer representing the index position of the element that we wish to remove from the collection. The default value of the pop function is -1. This means that if you use the pop function without passing in any integer value, that by default, the last element from the list will be removed. So for example, let's say that we wish to remove the last element from our list of exam marks. So the list that we currently have looks like this. And now we will call the pop function. And we will not specify any integer value. That's because we want to remove the last element in our list. And as we know, the default removal index for the pop function is -1, which alludes to the last index, hence last element in a list. I should mention that nothing would happen if you do specify an index of -1 to remove the last element. You can either type the extra 2 characters or simply leave the parenthesis blank since the function defaults to the same value. So essentially, we would like to remove 40 from our list. We would proceed to do so as follows. The full code script looks similar to this. You may experiment and change any portions of your code as long as you understand the logic behind these operations. And as we would expect, the last element, 40, has been removed from our list. Let us print the arrays before and after the pop operation. By now you should realize that Python script compilation and execution is sequential. So placing a line of code before operations occur would give you the former version of an object. Basically, to get the above output, which are the two versions of the same list, we simply add a print statement at the correct point in our code. Now, let us remove the second element in the collection. We will do this by specifying and using the pop function, and we will pass in the integer value representing the index position of the second element, which is 1. Exammarks.pop1. Also, don't be concerned by the numbers you may see in my code snippets. They are just the line numbers shown in the code editor in Spider IDE. Notice that upon running the script, our second element, which is 53, has been popped from the list. That is, it has been removed. Removing a value. To remove a value from a list, we may make use of the remove function. The remove function will take in one argument. You will specify the value that you wish to remove from the collection. I would like to mention that the remove function does not remove all occurrences of a value in the list. It will remove the first identical match that it encounters. For example, let's assume we have a list of fruits as follows. Fruits is equals to apple, orange, apple, banana, mango. For practice purposes, you can go ahead and explore indexing, slicing, popping, and other operations on the list before you continue. Now, let us attempt to remove the element apple from the list. We would do it as follows. Fruits.remove apple. And thereafter, if we proceed to print the contents of our fruits list to the console, we would do so as follows. Ideally, we know that there are two instances of apple in our list. So as per the logic behind the remove function, we would expect for the first occurrence of this element to be removed. Let us print the contents of our fruits list. Print fruits. We will see output as follows. Orange, apple, banana, mango. Notice that the first instance of apple has been removed from our array or list. We started with 5 elements, 2 of which were the same. Upon using the remove function while passing in a value of apple, one of the duplicate elements have been removed. Specifically, the first occurrence of apple that was encountered by the remove function. If you try to remove a value that does not exist in an array or list, you will get an error. Try it now by using the remove value and request removal of a value that does not exist in your collection. Reversing array or list contents. To reverse the contents of the array or list you are working with, you simply make use of the reverse function. Exactly the same as how we did using the slicing syntax, except that now you can perform the exact same logic and apply it to a collection using a built-in Python function. The reverse function does not take any arguments, so you simply need to call the function like so. Reverse. To reverse our array, we would do so as follows. Fruits.reverse. And to see the output of the operation, we print our array to the screen. Print fruits. Output will be seen as follows. Mango, banana, apple, orange. Sorting an array or list in Python. To sort the items in a list, we make use of the available built-in sort function in Python. The sort function in its default state will not require you to provide any arguments. It will simply sort all elements in your list in an ascending order. For example, suppose we have our list of fruits. Fruits is equals to apple, orange, apple, banana, mango. And we would like to sort the values within in ascending order. The aforementioned criteria is exactly that of the default behavior of the sort function. Therefore, we do not need to tamper with the settings and may use it as is. The sort function is probably the most important function in this section, not because of the level of difficulty nor the frequency of use, but instead because of the logic that works behind the scenes. The sort function will introduce us to a few new topics or concepts as we will see. The general idea is that the sort function allows you to enforce order within the values of a list. It will allow you to get all elements in a list to be ordered in either a lowest to highest or highest to lowest format. Let us analyze the sort function. Fruits.sort, upon which we print the contents of our list. Print fruits. Output of our array will show as follows. Apple, apple, banana, mango, orange. Notice that our values in the list have been arranged or sorted in ascending order. Do you recall the way we call the sort function with an empty parenthesis? The way in which we call it is the same as shown on the next slide. Fruits.sort key is equals to none, reverse is equals to false. Do you see the keywords key is equals to and reverse is equals to? These keywords are known as parameters. Do you recall instances when I said we will pass in arguments to functions? The arguments that we pass into these functions get stored by the parameters. The parameters are like built-in variables that have been created by the Python developers. These variables store the default behaviors and settings of certain functions in Python and may have their arguments altered to bring about a change in the logic of the function and therefore a change in the way our program logic executes and functions. The syntax shown above for the sort function displays the parameters for the function and the default arguments for the parameters. For now, I would only like to focus on the parameter called reverse is equals to. This parameter is holding a default value of false. False, as we know from previous tutorials, is a Boolean value of which there are only two that exist, the other being true. So, let us try the sort function again, but this time we will change the argument passed to the reverse parameter to true. Fruits.sort key is equals to none, reverse is equals to true. Now we print the contents of our array to the console and view the output. Print fruits. Output will show as follows. Orange, mango, banana, apple, apple. Notice that the list values are now in descending order. So we have just witnessed how the reverse is equals to parameter controls the order in which the contents of the list will be sorted. That is, either ascending or descending order, the default order being ascending. So that pretty much wraps up the work for this section on lists. Keep in mind that the sort function, we only tampered with the reverse is equals to parameter. We will explore the key is equals to parameter at a later stage in our journey. Not too later though, very soon. Also, in this tutorial, we looked at various operations that one is able to perform on lists and arrays in Python. It is good to keep in mind that all operations we have used on our lists and arrays are built in. They are available to us directly via Python and are not dependent on any third-party sources. Excellent. Thank you for watching and reading the tutorial up to the end. I do hope that you have learned new concepts about lists and arrays in Python. Thank you for your time.